triangle's vertices A, -3, 2, B, 7, 4, and C is 5, -6. Find the equation of the medians, AM and BM. Right, so there is A, and AM must be the median is the line that comes and it meets the opposite side bang in the middle. So that's the median AM. Now, it meets in the middle, so to work out this coordinate of M, we add the two x's together, so 7 and 5 is 12, and then we half it to give us 6. We've got 6, -6 plus 4 is -2, half it to give us -1. So now I've got the coordinates of A and the coordinates of M. So it's really basically back to your National 5 straight line. Work out the gradient. The gradient of AM is y2 minus y1 divided by x2 minus x1, which is -1 take away 2 divided by 6 take away -3. So when I work that out, I get -3 divided by 9. You've got to break down your fractions to its simplest form, which is -1/3. Now, once you have got the gradient, I've got 2 points on that line. I can either use A or I could use this point M to work out the equation. So I'm going to use the point -3, 2. We sub into y minus b is equal to m bracket x minus a. That's it substituted. So y minus 2 is equal to the gradient was -1/3 x, and it's got to be minus a, minus makes a plus. We're going to tidy that up, and when I tidy that up, I don't want that third, so we multiply it all by 3. So that gives me 3 times y is 3y, 3 times 2 is 6. When I multiply this whole side, that's a package, then that cancels. So I've just got -1 times x plus 3. Tidy that up, multiply your bracket with -1. When you multiply a bracket with -1, it changes the sign of everything in it. So that's -x and -3. And to finish it off, add 6 to both sides. And when I add 6 onto both sides, I get 3y is equal to -x minus 3 plus 6 is going to be plus 3. So that's the equation of AM, the first median. This one is the equation for the median B to N. So there's B, and it's going to cross to the middle of that opposite side. And the middle of that, add your two x's together, divide by 2. Add your two y coordinates together and divide by 2. So 5 plus -3 is 2, half of 2 is 1. 2 plus -6 is -4, half of that is -2. So there's the median there, B to N. I've now got 2 points on that median, so I can go back and work out the gradient the way we did again in National 5. So y2 minus y1 divided by x2 minus x1. So we've got 4 minus -2 divided by 7 minus 1. So that becomes 6 divided by 6, so the gradient of that line is equal to 1. So now we've got to work out the equation. I just need to choose one of those points. I've chosen 1 minus 2. Doesn't matter if you choose that one, they work out the same. So y minus b is equal to m bracket x minus a. Substitute. So y minus -2 becomes y plus 2. That's equal to 1, the gradient is 1, times x minus a, so x minus 1. Tidy your equation up, and that gives us, add that plus 2 becomes -2. That was 1 lot of x, take away 1, and then take away that 2 is -3. Now the next part of the question asks you to work out where those two lines meet. So that's the two equations. I can see I've got a -x and a plus x, so that's quite easy. All I have to do is add them together, and it makes that disappear. So 3y plus y gives us 4y. Then we've got an equal sign, and then -x plus x is 0. And also 3 take away 3 is also 0. So if we have got 4y equals 0, then that means that y is equal to 0. Divide by 4, 0 divided by 4 is still 0. So we're now going to sub y equal to 0 into, and the easiest equation to choose is y is equal to x minus 3. So y is 0, there's the x, there's the -3. So x minus 3 equals 0. And if x minus 3 equals 0, add 3 onto both sides. And when I add 3 onto both sides, I get x equal to 3. So the point of intersection in the question, they said it was called K. So K is the point, x number comes first, 3, 0. So in this question, triangle ABC has a vertex on the y-axis. Okay, no coordinates given for that one, but we know the coordinates of B, we know the coordinates of C. But they have told me it's on the y-axis. So what do we know about all points in the y-axis? The x number is 0. So we'll bear that in mind. So it says the equation of A to B, there's the line AB, is 7y minus 6x minus 21 equals 0. State the coordinates of A. So if we want to work out the coordinates of A, I'm going to take that equation, and I know that on that axis the x coordinate is 0. So I'm going to substitute that into that equation. So we've got 7y minus 6x minus 21 equals 0. We know because it's on the y-axis that x is equal to 0. So 7y, take away 6 lots of 0, which will be 0 anyway, minus 21 is equal to 0. So 7y minus 21 is 0. So 7y is 21. And if 7y is 21, then y is equal to 3. So A must be the point 0, 3. So that wee question a wee bit different. Okay, normally they give you all the coordinates of your points. This time they've been asking you to work that out. If you didn't spot that that was on the axis and the x number was 0, you would just make up a number because you're going to have to use that equation somewhere else. Okay, so if you didn't write anything in there and you get stuck and you couldn't do the rest of that equation, that question, then just make up a number and put it in there, make up a coordinate, and it lets you get the marks for the other bits. Don't just say, I'm stuck, and not do it. Right, so what have we got after that? It says, find the equation of the altitude from A. So we now know A, so it's important that we know that coordinate. And altitude is a line that meets the opposite side at 90 degrees. Now, I know A is the point 03, I've just worked that out. That's the only thing I know about that altitude. I don't know anything else about that. I only know one point. I don't know its gradient. Don't know another point. So to get the equation of this altitude, I've got to know what the gradient is, and I've got to know a point. That's fine. I've got the point there, but I don't know the gradient. So how do you get the gradient of an altitude? You work out the gradient of the opposite side, which is BC, and we know that the two gradients multiply to give us -1. Easier way to do that is flip and change the sign. So I'm going to work out the gradient of BC. So there's the wee picture there. There is BC, so the gradient is y2 minus y1 divided by x2 minus x1. So I've got 9 take away 1 divided by 7 take away 11. That works out to be 8 divided by -4. That gives us -2. Now I'm going to flip that gradient. So remember every number is -2 or whatever it is over 1. So I've put that in there just now for the purposes of the next bit. So we know gradient m1 times m2 is -1. Flip that and change the sign. So the negative becomes positive and it becomes a half. So the gradient of the altitude is a half. Now you must write this down. If you don't write that down, you will lose a mark. So now I know the gradient of that altitude. I know it's a half, and I know a point on the line is 03. Now, because that is your y-intercept, you can go in and do y equals mx plus c. So there is y, the gradient we know was a half, and c was 0.3. That's the equation of your line. If you didn't spot that, it doesn't make any difference. You can go in and do y minus b is equal to m bracket x minus a. So that would give you y minus 3 is a half bracket x minus 0. When we tidy that up, we get y minus 3 is equal to half x, that's 0. Now if you look at that one and that one, they're basically the same. The only difference is I've added the 3 onto the other side. But what we tend to do is we tend to get rid of fractions. So I'm going to multiply it all by 2. So 2y minus 6 is equal to x. And normally we've got the y term first, then the x. So we add 6 onto both sides, and that gives me the equation of the altitude. Now, I'm going to go back to the question, and we'll find out what the next part is we've got to do. So the next part is determine the coordinates of the point where the altitude, that's what we just worked out, meets the line BC. There's the line BC. I don't know what the equation of that is actually. I haven't worked that out and they haven't told us. But I have worked out the gradient of it, so that'll help us. Right, so we want the equation of the line BC. Right, so if we go down here, that's the altitude. I now want to find the equation of BC. Okay, I'm going to look back to find the gradient of BC because I worked it out when I was doing the altitude. So if I go back until I find the gradient of BC, there it's up there. So the gradient was -2. So gradient is equal to -2. Now I want any point in the line, I can pick B or C. I'll take the point B. And the point B, if I look back to that, point B was the 0.79. Okay. Right, so I've got a point, I've got the gradient, so I can now work out the equation. So y minus b is y minus 9 is equal to m times x minus a, x minus 7. So y minus 9 is equal to -2x's. -2 times -7 is plus 14. And I can finish that off. So I want to add 9 on to both sides. So we've got minus 2x's. 14 add on 9 becomes 23. So that's the equation of BC. Now we want to find the intersection of the altitude and that equation there. So I'll write down the two equations. We want to find where two lines meet. We solve simultaneous equations. So y is equal to -2x's plus 23, and the other equation for the altitude is 2y is equal to x plus 6. It doesn't matter which letter you eliminate, whether it's y or whether it's x's. I'm going to eliminate x's. So -2x's, there's one x there. I'm going to multiply that equation by 2. I'm going to keep that one the same. So y is equal to -2x's plus 23. And this one will give me, when I multiply it all by 2, 2 times 2y is 4y, is equal to 2 times x is 2x's, and 2 times 6 is 12. And I'm going to add those two equations because we've got different signs, so it's a dad's one. If you add them, they disappear. So y plus 4y is 5y. That is equal to, those two cancel each other out, and when I add 23 and 12, I get 35. So if 5y is 35, then y has got to be 35 divided by 5, which is 7. So now we're going to sub y equal to 7 into, pick one of the equations. I'll just pick the first one. So that is y is equal to -2x's plus 23. Probably the second one was easier, but it doesn't matter. So 7 is equal to -2x's, add on 23. And when we rearrange that, we get, I'll write it around the other way, -2x's, add on 23 is equal to 7. So -2x, take 23 away from both sides. I'm going to take 23 away from that. That gives me -16. So I'm going to finish that off, divide by -2. So x is equal to, negative signs cancel, that should divide by negative. 16 divided by 2 is 8. So the point of intersection, x comes first, is 8, and the y coordinate we know was 7. So we cross it 8, 7. So the next revision question, it says we have got a triangle here, angle x, we've got that side there, which is 1, that side there is 2. Find the exact value of this thing here. So whenever you have got a triangle, right angled, you work out if there's any missing side. So the hypotenuse, the biggest side there, is missing. So we're going to square that, add them, and take the square root. So 2 2s are 4. 1 squared is still 1. So 4 plus 1 is 5, so take the square root, so that side is root 5. Now, what we want to do is we want to work out the exact value of cos x minus 2 pi over 3. So we're going to look at our information sheet and find out what cos A minus B is equal to. Okay, so if you look at your information sheet, you know that cos of A minus B is cos plus sin. And then put your angles in an order. So that would be x, then it is 2 pi divided by 3, and then you get x and 2 pi divided by 3. Okay, we can work out cos x and we can work out sin x because there's the triangle. So I'm going to do that just over here just now. So cos x is adjacent over hypotenuse. Adjacent is 1, hypotenuse is root 5, so it's 1 over root 5. We're going to need sin x, so I'll work that out as well. So sin x is opposite over hypotenuse. So that's going to be 2 over root 5. So those two things I'm going to need in a second or two. Right, so I'm looking ahead and I see that I've got 2 pi divided by 3. Now this is going to be one of your exact values. I want to know what that is. So I'll do it both ways. So 2 pi divided by 3. If you want to change it to degrees, that's going to be 2 multiplied by 180, because pi is 180 degrees divided by 3. So 3 into 3 goes once, 3 into 180 goes 60 times. 2 times 60 is 120 degrees. Now, if you think of your diagram, which one, 30, 60 or 45 does 120 come from? It comes from the 60 one, so it's 60. 180 minus 60 is 120. So basically, we're looking at the exact values for 60, for cos and for sin, but it's in quadrant 2. Remember in quadrant 2, if we think about a cast diagram, in quadrant 2, all sin, tan and cos. So in quadrant 2, it's only the sin one that's positive, the cos one will be negative. Right, so what is cos 2 pi over 3? So cos 60 is equal to, I'll write this down here, so cos 60 degrees from your exact value table is root 3 over 2. But in the second quadrant, it's negative, so cos 120 degrees is the same value, but it's just a negative sign, is negative root 3 over 2. When we're doing sin 2 pi, that's sin 120, so we start with sin 60 degrees. Sin 60 degrees is equal to root 3 over 2. And it means in second quadrant we've got sin 60 is equal to, it's still positive, so it's root 3 over 2. Right, that one there, cos 60 is not root 3 over 2. Cos 60 is equal to a half. Okay, don't do what I did. Right, but it's still negative a half in that quadrant. Right, so all information we need should be here. So when I go in here and I do cos x is 1 over root 5 multiplied by cos 2 pi over 3, which is cos 120, is minus 1 over 2. And then sin x is 2 over root 5 multiplied by sin 2 pi over 3, which is sin 120. I'm not doing well here, which is root 3 over 2. Right, so multiply straight across the top, straight across the bottom. So 1 times minus 1 is minus 1. Root 5 times 2 is 2 root 5s. And do the same here. 2 times root 3 is 2 root 3 divided by root 5 times 2 is 2 root 5s. Now, same denominator, just make one big denominator and do the sum across the top. So it's minus 1 plus 2 root 3s. Because that starts with minus 1, I'm going to read it round the other way. So it's 2 root 3 minus 1, and that's that one done. For this one, determine the equation of the line shown. Okay, so we've got this line that's here and we want the equation of it. So they've given me this angle, so that's the angle it makes with the positive direction of the x-axis. So as soon as you know that, you're writing down gradient is tan theta. So we've got gradient is equal to tan 120. And tan 120, it must come from 30, 45 or 60, and it comes from the 60 degree one. It's in quadrant 2, 180 minus 60 is 120. So we want to know what tan of 60 is. So tan 60 degrees is equal to root 3. In quadrant 2, we're thinking about a cast diagram. It's only sign that's positive in there, so therefore tan is negative. So tan 120 degrees is equal to negative root 3. Right, so what we've got then is we've got the gradient is equal to negative root 3. And I know a point, I know one point there, that's a point 2, 0. So I'm going to work out the equation. Y minus b is equal to m bracket x minus e. Now, usually these are non-calculator papers. Keep your exact value, that root there. So y minus b gives us y minus 0 is equal to the gradient, which is minus root 3 bracket x minus a, so it's x minus 2. When I tidy that up, I've got y minus 0 is equal to minus root 3 times x, and that just goes like that, and minus root 3 times minus 2, two negatives make a positive, so it's 2 lots of root 3. Now that 0, I just can get rid of it, so y is equal to negative root 3x plus 2 root 3's. So next part of this question, after we've got the equation of that, it says hence write down the coordinates of b. So there is b there. So what do we know about the coordinates of b? It's on the y-axis. So I know b is the point 0 something. It's the y-intercept. So if a line is in the format of y is equal to mx plus c, we can read off c. That equation there is in that format. Y is equal to mx plus c. So c must be 2 root 3. So the coordinates of b are 0, 2 root 3. Now, if you forget that that's your c value, you know that x is 0, so y is equal to minus root 3 times nothing, which is nothing, plus 2 root 3, and that gives you your same answer.